Welcome to Lab 3, Black Hole Lab. So now we are going to enter the data into Python. So first, with the visualization, I added a radius to the star and also the origin, which is the black hole, so we can see it. So now I entered the data that they gave us. The mass of the star, the position of the black hole, and the time, delta t, the change in time. The first while loop calculates the velocity, which is taken from the star data CSV file that was given to us. After that, we take the velocity and we found the momentum by multiplying the star mass with the initial velocity and then the momentum final with the star mass timing the velocity of the final. And then in this one, we are calculating the star change in velocity and the change in momentum. Now we calculate dp dt. And according to the momentum principle, dp dt is equal to f net. And in this code, we are calculating the dp dt parallel. And we're adding p hat to show the direction of the momentum. And then after that, we are using Newton's second law to calculate the f net parallel. After that, we just take dp dt minus the parallel to get the perpendicular. And this is the equation I used to find the mass of the black hole, which is just a rearrangement of Newton's law of gravitation. The arrow scale was set small enough so we can actually see the visualization. And at the end, I put print black hole mass so we can see it. So now I'm going to run my program. As you can see, this is the black hole right here. And the blue arrow represents F net perpendicular. The black arrow represents parallel, F net parallel, and then the yellow represents the net force. As you saw when it got around here, that just shows the attraction. When it gets closer to the black hole, the attraction will be bigger. And when the star travels farther away, the attraction is less. So here, we can see that it prints the mass as 1.99 e to the 31st power. I also met the blue and yellow arrows, and the black arrows as well. Now to answer the question, according to the momentum principle, F net perpendicular, F net parallel, and F net is equal to the change in momentum over the change in time, parallel, and perpendicular. But they differ in the way that they are calculated. F net can be found through adding up all of the forces, while it is more difficult to calculate the change in momentum over the change in time because you have to use another formula, like in the program. Now for the what ifs. If there was another black hole whose mass that we do not know, but it has the same, it affects the motion of the observed star, could I tell the difference between the mass of the two black holes? No. The mass of a black hole cannot be observed because there is no degree of freedom in Newton's law of universal gravitation. Each variable is fixed. If one of these variables was changed, like the distance between a star and a new black hole, a new mass could be calculated. I also want to add that another difference between F net and the change in momentum over change in time is that F net actually affects how the stars move, while dp over dt only tells you how the stars move. Well, thank you for watching. Have a great day.